Okay, so the first four that I had were just for simplifying. So that's not any of the multiplication or any of the operations. It's just remembering how to find the most simplified form. So you want to think about your perfect squares. And I need a calculator. There it is. So 294. You want to think about what 294's factors are. So if you haven't already, if you go to y equals in your calculator, if you have a TI-83, and I am working on figuring out why all of you guys on Connect don't have access to a calculator on your computer. So hopefully we'll get that straightened out before second semester. But if you type in the 294 divided by x, you can see your factors here. So like 7 and 42. Ooh, sorry, I was doing something with another student. So your table start is at 1. Table gets back to the way y'all's looks. Second graph. Okay, so all your whole numbers are your factors. And what you want to do is try to find, obviously, like double whole numbers, and you would like to find perfect squares. So obviously 4, if that was a whole number, that would be great because the square root of 4 is 2. 49 with 6 is good because the square root of 49 is 7. So 6 and 49 would be probably the first one I would try. And if you choose one that's not far enough down on the list, it'll take care of itself. So the square root of 6 times the square root of 49 will give you the 249. The b, just know that this is b times b times b. And that we can look at them as square root, square root, square root. And the square root of b times the square root of b gives me a b. So then we're stuck with 1 square root of b at the moment. So b is going to go in the front, and a b is going to stay underneath the radical bar. So I know that the square root of 49 is 7. So that one's done, and that has to stick. Like I said, that b will stick. And then the square root of 6 can't get any better, so you just sort of clean this up. So it's going to be 7b on the outside because those were from the roots that worked out. And then square root 6b. And of course it would be a 6 beside a b because my 6 and b's look pretty much exactly alike. So then 7b times the square root of 6b will give you the same thing here. This is the reduced version of that. So then again, looking at 98 and just showing you in your calculator how to get your factors. So 98 divided by x, second graph. And again, you're looking for the ones that are going to give you a perfect square. So like 2 times 2 is 4. So 4 is a great one. 9, 16, 25. Any number like that is going to get you quickly to the simplified form. And again, you can work your way down slower than that, but that is the ideal way to go about it. So 2 and 49 would probably be my best bet at the moment. And I have r to the fourth, which is r squared times r squared. And that root and square gets rid of those. So r squared comes out because r squared times r squared, when it's a root underneath it, the roots get rid of themselves and you're left with whatever's in the bottom. So if I simplify r to the fourth, take the square root of that, you end up with r squared, and that's going to go on the outside once we're done. Square root of 49 is 7. So we're done with this guy. Square root of 2 can't be reduced any better. So it's going to be 7r squared square root of 2. Ask me a question or slow me down if you need to. I'll try to keep an eye on your conversation box over there. So then 27, and you probably know the factors of 27, but again, if we were to look at them here, so you have 3 and 9, 3 and 9, and that's really it for your whole numbers. So square root of 3, square root of 9, if we're just looking at the 27. And then remember, k to the third is the same thing as the square root of k squared, and then the square root of k. So square root of k squared gets rid of it, and a k comes out because k times k. Or the square root gets rid of the squared portion. This guy is stuck. It can't get any better than this. This can't get any better than this. Square root of 3 is done, and then the square root of 9, we hopefully know, is 3. So we have a positive 3. Now, anything without our root bar is going to be on the outside. So 3k. And then we have our root, square root of 3k. So it's 3k, square root of 3k, put together is your simplified version of 27k cubed. So we have 48 as well. And the most simplest, and this one has a lot more whole numbers. So you have 48, which is not terrible, but that's not a perfect square. 24 is not a perfect square. 16 is, though, because 4 times 4 is 16. So I would go with this one because the rest of them is 12, 8, and 6, which you will finally get down to the end again where it's good, but it'll just take a lot more steps. So let's do square root of 3, square root of 16. If I multiply those together, it's going to give me the square root of 48. P to the fourth, again, is p squared, and they're both under the root bar. And anything times itself times the root bar gives me out whatever is underneath that root bar. So we have p squared for sure. That's going to come out from underneath root bars. Square root of 3 is stuck. It doesn't get any better. And the square root of 16 is at positive 4. So it's done. So I have 4 p squared square root of 3. And so that's it for your simplifying practice for right now. Getting into multiplication, so you multiply like things. So it's kind of like combining like terms, but now we're doing multiplication. So radicals multiply with radicals, whole numbers multiply with whole numbers if there happens to be 2 of them. And now that I'm looking at these examples, there isn't, none of them have 2 of them. But if we pretend like there's an imaginary 1, so that's 5 times 1, and then the square root of 3 times the square root of 5 is going to be the square root of 15. Now, make sure that at this point, we double check and make sure this 15 can't be reduced, which it can't because square root of 3 and square root of 5 are the most simplest form of that as well. So 5 square root of 15, and we're done. Look at number 6. I have the square root of 6, and we can put imaginary 1s in front of these guys if you want to. So 1 times a negative 1 means we are going to have a negative that comes out. So negative 1's going to be on the outside. And then square root of 6 times the square root of 10 is the square root of 60. 60 likely to have some good roots that we can simplify. So I have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 6 and 10. Not beautiful, not perfect yet, but we should be able to get it down some. Let's do 2 and 30. So square root of 2, square root of 30. Square root of 2 is going to always be the square root of 2. It can't get any better. Square root of 30, we could do square root of 2, square root of 15. Now, when you see 2, so 30 is done, 2 roots, remember square root of 2 times the square root of 2 is going to give me out 2 because that's the square root of 4. And so ultimately, I guess this is kind of where I was saying you'll get there eventually, but square root of 4 times 15, because 4 would give you that perfect 2 already, might have been a better starting point if you saw it. So we know we have a negative 1, a positive 2, because these guys canceled out to a positive 2, and then that square root of 15. So it's going to be a negative 2 square root of 15. And that's your answer for that one. Number 7, so 15 times 5. Oh, sorry. 15 times 5 gives us 75. But don't stop there, because again, you want to make sure you know whether or not you can reduce it. So 25 is one of the first numbers I think about when I think about 75. And it's 3 times 25. And 25 is a perfect square, so it's not a terrible place to start. Square root of 3 is going to stay square root of 3. 25, the square root of 25 is 5. So this answer is going to be done at 5. 5 square roots of 3. And then number 8, again, so negative 3 times an imaginary 1, so we have a negative 3. And then square root of 3 times the square root of 3 is going to be square root of 9. But we know the square root of 9 is 3, so negative 3 times a positive 3. Your final answer for this guy is actually that whole number, negative 9. We okay so far? Am I going too fast? Okay, so then we're going to distribute. So same idea. This was like monomial times monomial, so single by single. But we're just going to distribute. So the square root of 6 times the square root of 2 is going to give me the square root of 12, which we'll go back and check and see if we can simplify that. And then 6 times the square root of 3 is going to give me square root of 18. And so we want to make sure those are in their simplest form. Hopefully you already know that 12 is divisible by 3 and 4. So square root of 3, square root of 4. That 4 is going to give me a 2. So this is going to be 2 square roots of 3 in its most simplified form. Then we have a plus in the middle. And we'll do the same thing for 18. 18, I always think of 9 first, which is great in this case too, because again, that's a perfect square root as well. And that's going to give me a positive 3. So it's 3 square roots of 2. And you can't add these unless they are the same. So these are not like terms. So you're going to stop right there. And we'll get into addition and such tomorrow or a little further down the line. Square root of 5 times 2. So that is not another root. So we're just going to rewrite 2 times the square root of 5 plus square root of 5 times the square root of 10 is going to be the square root of 50. We want to simplify that 50, and that would be, I'm going to do 25 again. Yep, square root of 2, square root of 25. 25 becomes 5. Square root of 2 is stuck, so we got square root of 2 in this one. So our 2 square roots of 5, which can't be reduced, plus 5 square roots of 2 would be the distribution of that multiplication. Let's see what else I got. And then, so 15 times the square root of 15 times 2. You can't combine them, so you're just going to rewrite it. 2 square roots of 15. And that's all, as far as you can go with that guy for right now, because 3 and 5 won't get any better. There's not like a perfect root from 15. And then square root of 15 times 6. So 15 times 6 gives you the square root of 90. So it's plus the square root of 90. That one can be broken down some. So if I do 9 times the square root of 10, because 9 is another perfect root, this is going to turn to a positive 3. So our final answer for this one is 2 square roots of 15 plus 3 times the square root of 10. And then we're good there. As far as just remembering to distribute and how to distribute these guys. So 15 times 3 is going to be the square root of 45. 15 times 5 is 75. So square root of 75. And we want to check both of them and see if they can be reduced. So 45, if we divide it by 9, we get 5. So square root of 9, square root of 5, because 9 is another one of those perfect roots. So just try like 2 times 2 is 4. 45 isn't divisible by 4. 3 times 3 is 9. It is divisible by 9. So we know we get a whole number 3 here. So that means we have 3 square roots of 5. 75, like I said, I always think of 25. And the square root of 25 is 5. And square root of 3. And this is addition in the middle. And that's as far as you're taking it for the moment. Number 13, so square root of 5 times the square root of 6 is going to be the square root of 30. Square root of 5 times the square root of 5 is the square root of 25. Square root of 30 doesn't get any better because it's 3 and 10, or 5 times 6, which doesn't get any better. So we're going to keep that one. But the square root of 25 is 5. So your final answer should be square root of 30 plus 5 for the distribution of that square root of 5. Square root of 15 times 5. Again, this is not a root, so we're just going to write 5 times the square root of 15. And then square root of 15 is only going to mess with that 10 here. So that means I have 5 times the square root of 150. And 150, hopefully, we definitely can simplify. So you want to think about your factors on 150, and that's not one of those numbers most of us use again very often. So if you want to save yourself some time, you can type it in your y equals and then hit second graph. Look at your whole numbers. 2 and 75, 3 and 50, 6 and 25 looks good to me. So 6 and 25, because we know that this 25 can turn into a whole number 5. So we have a whole number 5, a whole number 5, and then the square root of 6. 5 times 5 is 25 square roots of 6 there. And then to rewrite as correct answer for this one, it'd be 5 square roots of 15, because he was already in the best shape he could be in, plus 25 square roots of 6. I am just, as far as like repetitiveness, going to skip to number 16 because it's a little bit different, and number 15 is much like the ones we've already been doing. Actually, we'll go and do 15. So square root of 3 times square root of 3. It's going to give me the square root of 9, which we know is 3. Square root of 3 times 4 is going to give me 4 times the square root of 3, because those can't be combined again because one's a root and one's a whole number. Looking at number 16. So this negative 5 is going to be times negative 2, which is going to be 10. That 5 is going to be times 10. So 10 square roots of 50. That one we know. Hopefully you know that that's going to be 25 is in there, so we can make that one better. But we'll give it a second. So negative 5, there's not a number in the front, so it's just going to be negative 5. And then the 5 root times the 3 root is going to give me 15. And 15 is stuck the way it is. Sorry for the slide. Negative 5 is fine there. We just got to work on our 50. So if we're looking at our 50, we can do 25, and it's going to be 2. Square root of 2 does not get any better, but the square root of 25 is 5 times 5. So we have a whole number 5 and a square root of 2, but we also had the whole number 10. So 10 times 5 is 50 square roots of 2. The other way you can check these, if you get your answer and you're not 100% sure, you can type this in your calculator or in Desmos or wherever you are, and then you can type your answer choice in there too. And it's going to give you out a decimal, but the decimal should match, would be how you could check and make sure you're doing okay. And then so, sorry guys. And then minus 5 square roots of 15, or plus a negative, which is the same thing as subtraction. When you get into the variables, it's the same idea. The variable just moves with it. So negative 4, there's a 1 here, so that's still going to be negative 4. 15 times 2 is going to be 30, and there's that n. And then that 1, there's nothing here, so we're good. So 15 times 3 is going to be 45n. And then we want to see if we can simplify that 30 or the 45. 30 is 3 and 10, 5 and 6, like we already discussed. So that one can't get any better, so we're pretty good here on the front. But 45 can probably get better. 3 and 15. 5 and 9. 9 and 5, which means this turns into a 3. Square root of 5 sticks because it's done. And the n is just with it. It just stays underneath the root bar. So our final answer is negative 4 square root of 30n plus the 3 we just factored out, 5n. It's the most simplified form. And so what I meant by as far as like plugging in your calculator, so if I have the square root of 15 with a variable, I'm sorry, I'm lying. Now that has a variable, it's not going to plug in. You could arguably graph it in Desmos, and it should graph on top of each other. If there's no variable, definitely can put it in your calculator and get out a decimal. With the variables, though, you're probably best off just graphing it and seeing if they match. So one more. Square root of 3 times the square root of 2 is going to be the square root of 6. Square root of 3 times 2x. You can't combine those, so you're just literally going to write plus 2x times the square root of 3. Square root of 6 does not get any neater because it's 2, 3, 1, and 6. None are perfect squares, so you are done there. How we feeling? All right, cool. So the last one, 3 times 6 is going to be 18. R times R is R squared. As soon as you see that R squared underneath the root bar, we know that that's going to come out. Because if you square root anything that's squared, it comes out. We're going to neaten this guy up in a minute. 3 times 4, that 4 is outside. So this guy is in its neatest form at the moment. So 18 is the one we want to deal with. And that's 2, 9. 9 turns into a 3. Square root of R squared is going to give me out an R. So square root of R squared, the root and the squared goes away. Or you can think about it as R times R, the same as 3 times 3 gives me a square root of 9. So it's going to be 3R square root of 2 plus 4 square root of 3R. Last but not least, 6m. So the 2 is just going to stick because it's not under the root bar. 6 times 6 is 36m. Hopefully you see that 6 and 6 and know that this is going to have to be reduced. 6m times 10m is going to be the square root of 60m squared. Again, you see the squared, so hopefully you know the m is going to pull out already. But the square root of 36 is going to be 6. So we have a whole 6, and then we have the square root of m, still waiting because m is not squared at this point, so it has to stay under the root bar. So that 2 times 6 is going to give me 12 square roots of m. Looking at 60, and then m squared if you want to think of them separate. M squared, taking the root, is going to give me an m, so we're done with that one. 60 we could do 4 times, and I just lost it. 60 divided by 4 is got to be 4. 15, yep. Square root of 4 is 2. So we have m and 2 on the outside, and the square root of 15. So 2m square root of 15. And then you're done. And that's all of our notes for today that I had printed.